Today we are working on exponential functions. They are in the form of y equals a times b raised to the x power. So the a might be a 1, so you might not see a number there, but usually it's a number times a base raised to an x power. Notice that the x is in the exponent position. So exponential functions are defined by an equation in the form of y equals a number times a base raised to an x power. If the base is greater than 1, so the function is an exponential growth. And is increasing as time goes on. If b is a fraction or decimal in between 0 and 1, then it is an exponential decay. And as time goes on, it is decreasing. So if your base is 1/2 or 1/3 or 3/4, it's exponential decay and it's decreasing. So an asymptote is a line which the graph gets close to but never touches or crosses. So let's classify as an exponential growth or decay, and then create a table of values and graph, then identify its key characteristics. So the first one we have is y equals 2 raised to the x power. Sorry, had to grab my calculator there. All right, so because the base is bigger than 1, we know it is growth. The 2 is bigger than 1, so it's a growth. And if I put this into y equals on my calculator, I would type in the 2, and then I would hit the caret button to open an exponent box. And then in the exponent box, I would put an x. I get the x by doing the variable button, which is XTON. It's next to the green alpha button. So I have 2 caret button x in the exponent position and enter. And then to get to my table, I hit the blue second button and table. All right, and we want to plot some points here. So I pick -2.25. Yes, there's decimals going on here. -1.5. 0, 1, 1, 2, and 2, 4. Again, those are just points that I copied off the table on my calculator. So I'm going to start at the origin, go to -2, and go just a hair above the x-axis. Go to -1.5 is between 0 and 1. 0, 1, over 1 up 2, and over 2 up 4. And it keeps going from there. So it will continue to the left. So I'm going to put an arrow on that end, and it will continue up to the right. So I'm going to put an arrow on that end. And this is an exponential growth. As you read it going from left to right, it is going upwards. So notice it. If you look on your calculator, it will never actually hit the x-axis. So that is our asymptote here. The x-axis equation, you could write x-axis, or you could write y equals 0. Remember, horizontal lines are y equals a number. So this is the x-axis. So it gets really close to the x-axis, but it never actually touches it. All right, so the domain and range we did earlier this year. The domain is from left to right. In this case, the arrows show that it continues on to infinity in both directions. So that means all real numbers. And let's remember the symbol that we learned earlier this year for all real numbers. Capital I with an R next to it. It's a capital R with an extra line is what it is. And then the range is from the bottommost point to the topmost point. It will never come down and actually touch the x-axis. It's all above it. So the y values are all greater than 0. And the y-intercept is where it touches the y-axis, which is at the point 0, 1. Let's try another one. So this time our base is 1/4. That is a number between 0 and 1. So therefore this is an exponential decay. You'll notice when we graph it, it goes downwards as we read the graph from left to right. So again, we're going to y equals on the calculator. We're going to open a fraction by hitting alpha y equals. And we're going to open a fraction and put 1 on top, 4 on the bottom. And then we're going to hit the caret button to open up that exponent box. The caret button is over on the right-hand side below clear. And we're going to put in the variable in the exponent box. It's the x, looks like x ton. That is next to the green alpha button. And then go to our table by hitting second table, which is above the word graph in the upper right corner. So from my calculator, I have -2, +16, -1, +4, 0, 1, 1.25, and 2.0625. So -2, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wow, that's like way up here. All right, and then -1, +4, and 0, 1. Jeez Louise. There we go. And 0, 1. And then over 1 up 0.25, over 2 up 0.0625. So you'll notice on the table on your calculator that these points are getting closer and closer and closer to the x-axis, but they never actually cross the x-axis. So, whoops. So they get close, 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 but never actually touch it. So the domain is from left to right. There's an arrow on both ends, so it is all real numbers. So that capital R with the extra line through it could be all real numbers. Range is from the bottommost point to the topmost point. It levels out there. There's a limit on the bottom. All the y values here are greater than 0. The y-intercept is the point 0, 1. And the asymptote is the line it's almost touching, but it never actually touches. In this case, again, it's the x-axis, which is y equals 0, also known as the x-axis. Let's try one more. So again, we're going to the calculator. We're going to go to y equals. On the calculator, we're going to type in a 3 and then use that caret button over on the right-hand side to open the exponent box and put x in the exponent box. And then, careful, you have to hit your right arrow to get down to the regular line in order to put in -1. Okay. Oopsie daisies. I just wanted to put the 3 in there. Okay. So right arrow to get down to the regular line. Otherwise, your -1 is still going to be in that exponent box that you opened with the caret. So once you have that in your calculator, you're going to go to second button and table. which is above the word graph in the upper right corner. And then from our table, we're going to do a few points to the left of the axes, a few points to the right. And we have -2, -0.8 repeating, -1, -0.6 repeating, 0, 0, 1, 2, and 2, 8. So try your best here. -2, -0.8 repeating is almost down to -1 there. -1, -0.6 repeating is a little bit more than halfway down. 0, 0 is the origin. Over 1 up 2, and over 2 up 8. 6, 7, 8. There you go. So you'll see that because the base is +3, it is exponential growth. Let's put arrows on both ends. It's almost touching the line y equals -1, but not quite. So there's that asymptote there. You'll notice it gets closer and closer to y equals -1, but it never actually touches it. It's growing because the base being raised to the x power is 3, which is bigger than 1. The domain from left to right are arrows to arrows, which is all real numbers. So that capital R with the extra line there. The range, it's all above the line y equals -1. So the y values are all greater than -1. And the y-intercept is the origin, which is the point 0, 0.